Good afternoon. Let me introduce myself. My name is Olha. I'm a student of the master's degree program of computer science at Khmelnytskyi National University, Ukraine. I'm pleased to present you the topic of the research, abusive speech detection method for Ukrainian language used recurrent neural network. The terms and conditions of the vast majority of social networks and messengers clearly define consent requirements and acceptable standards of user behavior. For violation of such rules and regulations, social networks usually block either content or accounts. All social media platforms, including Facebook, Twitter, YouTube, have made huge investments and developed policies to identify and moderate such harmful content. The aim of research is to create and validate a method for automated determination of the level of social acceptability of textual internet content based on a combined approach that includes sentiment analysis using RNNs and verification with a dictionary of offensive words. The main contributions of this research are follows. A method for detecting offensive language in textual internet content for the Ukrainian language using a recurrent neural network has been developed, and the developed method allows detecting offensive speech with a given user threshold. Also, we faced some challenges during the research. There are no appropriate methods for automatically detecting obscenities and hate speech in Ukrainian language, as the development of such methods is a hard and difficult task for several reasons. There are no labeled databases of Ukrainian language corpora of commands or social media posts with an offensive content due to the peculiarities of word formation in Ukrainian language. It's almost impossible to determine a list of offensive words. Users often invent new obscene words by connecting two common stems with an infix or adding prefixes or suffixes, and the use of surjik gives rise to a wide variety of swear words. The Ukrainian Twitter corpus for RNN trading and the abusive language dataset for identifying offensive content will be used as experimental data to implement the method of detecting offensive speech. Here you can see components and stages of the method for detecting offensive speech for the Ukrainian language. An explanation of how the method works is shown on the next slide. Step 1 is a neural network assessment of the sentiment tone based on a pre-trained RNN model. The result of this step is a numerical assessment of the content sentiment in the range from 0 to 1, where 0 is completely negative and 1 is completely positive. Step 2 takes place in parallel with the first step and consists in assessing the frequency of the occurrence of offensive language, which will be determined by comparing the content of the message with the dictionary of offensive language. The frequency of offensive language will be calculated using the next formula. At step 3, the offensiveness score of the textual content is calculated based on the tone of the sentiment and the concentration of offensive components. The numerical assessment of the offensiveness of textual content will be calculated using the next formula. Accordingly, the output data of the method is a numerical assessment of the offensiveness of textual internet content. Here you can see stages of forming trained RNN sentiment analysis model for detecting offensive speech. Also, we developed software, and here you can see some practical approach. For example, the acceptable negative feedback was given, and unacceptable negative feedback was given and calculated. As can be seen from table, in general, all models cope with the task, but given the purpose of the study, it was decided to use V5 model, which has the highest accuracy. Although the V7 model also has high recall and F1 values, it's more important to identify negative samples more accurately. Here you can see classification of reviews by models. And as you can see from the diagrams above, the metrics do not decrease below 94%, so the neural networks show high performance in all models for classifying the sentiment tone of text content. The result with examples of how the method were used are also shown here. For comparison, the same comments were submitted for the GPT chat evaluation. Here you can see the result of the applied use of the method and evaluating comments with GPT chat. So, developed models for detecting offensive speech for the Ukrainian language using recurrent neural network, which includes a combined approach. The RNN network for determining the numerical assessment of the sentiment tone of content, and approach for numerically assessing the concentration of offensive components. Also, the labeled multilingual dataset for training the neural network was developed. To train the RNN, it was decided to divide the dataset in a 60-40 ratio, where 60% is the training sample and 40% is a test sample. The trained RNN model, which has subsequently used for sentiment analysis, had an accuracy score of 0.96. Recall score of almost 0.96, and F1 score is almost 0.96. The proposed method also has a number of limitations. It doesn't work with text content of 3 words or less, and no more than 500 words. Further research can be directed towards practical applications, which can be a useful tool for assessing the level of social acceptability of digital textual content published on social networks, and for preventing the spread of harmful or offensive information. Thank you for your attention.